Okay, so this is example number 1. So which is you have a cantilever beam of length L equals to 2 meter, which supports a point load at the end of the beam, which is equals to 8 kilonewton. The beam is made of wood, which having a cross-sectional dimensions of 120 millimeter times 200 millimeter. Okay, so you have to calculate the shear stress due to the load P at points located 25, 50, 75 and 100 millimeter from the top surface of the beam. Okay, so from this result you have to plot a graph with showing the distribution of shear stress from top to bottom of the beam. For the solution, you have to determine Q, I and T, okay, in order to substitute it into the shear formula. Okay, so as we already discussed in page 11, okay, so we can determine the shear stress at any point using this equation, okay, at y, okay, at any y. Okay, so you have to replace what is the y value. Okay, so for this case, y is at 0, which is at 100 millimeter. Okay, so this is equivalent to 100 millimeter from the top surface. Okay, so and then I have y equals to 25, y equals to 50 and y equals to 70. Okay, so this one is actually measured from here. So this is the neutral axis and this is y equals to 0 at neutral axis, and then I increase y equals to 25, y equals to 50 and y equals to 75. So basically this is y equals to 75 mm. Okay, and then next is to find tau. Okay, so you just need to substitute the value of y here. Okay, 0, 25, 50 and 75. Here you will get this answer. Okay, as we know, at y equals to 0, we can get the maximum of shear stress. It is equals to 0.5 megapascal or equivalent to 500 kilopascal, as you can see here. So we can plot 500 kilopascal here. And then next is at y equals to 25. So this is at y equals to 25. Okay, and then we got 469 kilopascal. And then you can see what is the value for shear stress at point 50 and point 75 from the neutral axis. Okay, here and here. Okay, so since the beam is symmetry, so you just need to mirror this one. You just need to copy, and then you can get the shear stress at the bottom part. So basically, for the shear stress, we have a parabolic arc. Okay, so we have this parabolic arc, which is it is 0 at the top and bottom surface of the beam, and the maximum value is at the neutral axis. Okay, so this is the example number 3. So you have to plot the shear stress distribution acting over the beam's cross-sectional area, given the shear force is equals to 80 kilonewton. Okay, so 80 kilonewton acting here. This is the solution. Because this I-beam is symmetry, so you only need to determine the shear stress at point B prime, point B and C, where point B and B prime is actually on the same point, but B prime is for the shaded area, which is flange, and then B is for the web. Okay, and C is at the neutral axis. Okay, so you can determine the I value using this equation, which is for web and also for flange, and then this is the answer for the I value. Okay, so determine the shear stress at point B prime, which is associated to this flange. So the width of the beam is equals to 0.3 meter, and you have to determine what is Q, and then substitute all this information. Okay, tau B prime is equals to 1.13 megapascal. Okay, next the same procedure, which is using TB equals to 0.015, because this width is associated to this web. Okay, but then the Q, you can just use the same Q as here, because point B and point B prime are at the same point, so you just need to use the same Q. Okay, so substitute all this information, you will get tau B is equals to 22.6 megapascal. Okay, then continue with the calculation of shear stress at point C, which having the width TC is equals to 0.015, because C is located here, and T is associated to the web. Okay, and then you have to calculate what is the Q. So now you have to calculate what is Q, because Q is always depending on Y prime. Okay, so you have to determine the new Q here, and you will get 0.735 times 10 to the power of negative 3. Okay, so substitute all the information, and then you will get shear stress at point C equals to 25.2 megapascal, or equivalent to the maximum shear stress. Okay, because shear stress is always maximum at the neutral axis. So you can plot the stress distribution as like this. So as we discussed in previous slide, for the flange, okay, for the web for the beam which having wide flange, okay, so there is a sudden jump in between the flange and also web. Okay, so as you can see here, so this is tau B, and then this is tau B prime. Okay, and this is tau B. So we have a sudden jump of the shear stress here, and then we have a parabolic here, and the maximum value is 25 megapascal. So basically you just need to calculate at the upper part, and then you can just copy or mirror the value here for the bottom side of the beam. Okay, for example number 4, you have a hollow steel box beam which having a rectangular cross section as in the figure. Determine the maximum allowable shear force V that may act on the beam if the allowable shear stress is 36 megapascal. So in this question, instead of finding the allowable shear stress, so you have to determine what is the allowable shear force V. Okay, so when you have this hollow rectangular shape, so it is also equals that you extract it is also equals that segment A is minus segment B. Okay, so segment B is the inner size of this beam. Okay, so for all the calculation of I and Q, okay, so first you have to determine for the whole outer part, and then you have to extract this one for the inner part, which is B. Okay, so you will get I is equals to 454.9 times 10 to the power of 6, and then for Q, so you will get 1.28 times 10 to the power of 6. Okay, so next is, okay, so now you can proceed the calculation, which is we have this shear stress equation. Tau is equals to VQ divided by IT. Okay, so since the question asks you to find the allowable shear force, so you have to rearrange this equation, and then it will become shear force allowable is equals to shear stress allowable times I times T and divided by Q. Okay, and then you will get the answer for the allowable shear stress equals to 273 kilonewton. Okay, so that's all from me for this topic, which is on shear stress. So if you have any questions, you can ask to your lecturer. Okay, so thank you very much for listening. Assalamualaikum.